Just so you know, this is done by a design team outside of the IETF. Been meeting for about 3 years, and many of them are in this room, and it's a conspiracy of operators and vendors and computer scientists and even government people. So, on Sunday, I did a workshop here on the resource public key infrastructure, which is an X509-based hierarchy, describing address space. You know it's being rolled out by Aaron and the other registries. Let's assume also that route origin authorizations are there, so we have a way of formally and cryptographically verifying that AS2 has the right to announce that prefix. Let's assume that we have a way of getting this into routers, and by the way, by assume, we have current running code, and on Sunday we had a workshop doing it. So it's in routers, and so the routers can actually decide that, hey, that prefix should not have been announced by this AS, but this announcement from this AS is okay and can be tested, and you can set your routing policy based on a validation state of formal cryptographic verification all the way up to the allocation from the IANA to the registries. The problem with this is simple, that this relied on data which, although the allocation trace is cryptographically assured, the BGP announcement, the origin AS that we saw here, is not cryptographically assured. So I can forge the origin AS that matches the RPKI. So, and therefore sneak past this because there's no crypto assurance of the AS origin or path. Now, this does not make the RPKI-based Origin Validation useless. It's going to get the YouTube incident, 7007 incident, 128/9, big messes on the internet that were unintentional. It just doesn't stop malicious attacks, a whole class of malicious attacks. Okay? So it deals with the accidental misconfiguration, but not malicious attacks. That's life in the big city. Can we do something about that? And what we can do about it, we're calling full path validation, okay? Which is per prefix AS path validation cryptographically to protect against forgery of the origin and to protect forgery of the AS path. A monkey in the middle attack, as Tony, who spoke a moment ago, and Alex demonstrated at DEF CON 2 years ago, okay? By stealing the whole show network with nobody able to detect it. Yes, if you follow the internal IETF wars, this is SBGP-like, not SOBGP-like. SOBGP was based on something that in published AS relationships, similar to the way the IRR publishes it. And so it showed that this could be the valid path because A was connected to B. But the problem is the policy on the global internet changes every 36 milliseconds. That has been measured. No, it hasn't. That's a joke. Sorry. And because new circuits come up, new relationships are formed, new customers are turned up, circuits break, et cetera, et cetera. Routers never break, of course. And so what we have is a protocol to distribute policy right now. It's called BGP. Okay? That tells you not whether Mary should have announced the prefix to Joe, but it will tell you that, oh, pardon me, Bob, it will tell you that Mary did announce it to Joe. We cannot guess Mary's intent. We cannot guess Mary's business model, etc. Whether she should have announced it to Bob, we'll never know. Whether she did announce it to Bob, we can formally validate. So the purpose of this exercise is to validate that the protocol is correct, to deal with attacks on the protocol, not to deal with attacks on business policy or intent. Okay? I'm going to give you a simple attack. Much more complicated attacks are the interesting ones. It would be great if Tony gave his talk again. But router B announces its prefix to W, announces it to X, announces it to A. W also announces it to Z. Z lies. Z tells X, I have a direct connection to B. That makes it a competitive path. Tiebreaker says, oh, money goes this way. Z steals it, sends it back on its way. Okay, it's shortened the path. What we're going to use to prevent it we'll call forward path signing. And that is when ASN sends an announcement forward to ASN plus 1, it signs the announcement saying, I am N, I am sending it to AS1, N plus 1. Okay? So that when B sends the announcement to W, B signs it with B's private key that, hey, I am B, I am sending it to W. Okay? Furthermore, when W sends it onward to X, or more interestingly to Z, it says, hey, I am W, I'm using my key to sign towards Z and encapsulate the previous signature. Now B cannot say that it is Z cannot say that it is directly connected to B because it does not have an announcement from B signed with B's private key saying B is sending it to Z. So Z cannot make that lie. So the traffic now, this lie doesn't work. This guy gets the announcement that says, hey, take the money, send it here, send it here, send it here. So the money now goes to B, which is very good because it stands for Bush. Okay. This is meant to be a capability. It's a change to BGP. It's a protocol change, and I'll even show you packet. It is meant to be a capability negotiation that consenting routers at the edge agree to use. It's meant to be at the edge of my AS, towards the edge of your AS, and they negotiate the capability just as we negotiate multicast or IPv6, et cetera, all the other capability negotiations. Because there are signatures in the packet, they're going to take, we need to extend the PDU for BGP. You probably, nobody ever thinks much about it, but a BGP message is limited to 4K today, and there's a proposal, internet draft in the IDR working group to raise that to 64K, so you can fit signatures up the yin-yang. If this capability is not agreed, in other words, you are not a secure BGP speaker, I strip all the garbage before I send it to you. One other attack that's interesting, let's call it a replay attack, is R0 announces its prefix saying, hey, here's the path to R1. R1 announces this path to R3, and so on and so forth. Okay? R1 has an announcement that it has from R0. If R0 changes providers to R2, R1 could replay that old announcement and fool R3 into sending the traffic this way instead of this way. Okay? How might we prevent that? We might prevent it by having R0 sign the announcement to R2, I believe it was. No, R1. R0 sign to R1, and that signature has an expiration. And that window of expiration, hey, this signature is only good for 4 days, means on the 5th day, R1 cannot lie about it. So it's not, I cannot prevent replay, I can only reduce the window of opportunity for a replay. Okay? So freshness is critical. The announcer signs with a relatively short signature lifetime. The origin re-announces the prefix. Well within that lifetime, we call it beaconing. Okay? And the suggestion is on the order of days, but if it's, critical infrastructure, maybe it's on the order of hours. Of course, we all think our infrastructure is critical, but you're talking about something, if misused, could create a significant amount of BGP traffic. So this will be limited, probably both socially and technically. Each router wants to have a private key. I probably want all of my routers to have different private keys because I don't want a compromise of the Denver router to lead to an automatic compromise of the San Francisco router. So there's a more complex certificate and key distribution mechanism in the RPKI. There's a cute hack that might be usable, which is a router could generate its own private key and send it to the RPKI to be signed, and then the private key would never have left the router. For small networks like my personal garbage, I probably will use one key for all the routers in it. Okay? And it looks kind of like this. This is the extension, is the AS certificate of the RPKI, signs, router, blobs. Okay, and each one of these is the ASN number and the router ID and the public key. Okay, here's what it looks like. I did promise packet porn. Today you have an NLRI, the prefix, and your AS, and you forward that on. If you do this, what you do is you also have a reference to the certificate of the router. You have the forward signature. I am AS0, I am sending it to AS1. This glob is hashed and then signed with the expiration of which I spoke, and that signature is appended here. So this is a new optional transitive attribute tacked on the end of the NLRI plus AS number that we know and love. The next router, when it sends it on, does something very similar, right? It signs, well, first it says, I am router X, this is a pointer to my cert, and this is the next AS I am sending it to, the forward signature. I hash over it and sign it without an expiration. This is the signature with the expiration, and the signature goes here. I want to sign over the incoming signature, but I don't really have to. All I have to sign is over the signature here, not the whole blob, because it's cryptographically equivalent. As I said, it's only at the provider's edge. It does not protect the iBGP at all. It does not protect iBGP. Inner provider. Of course, your iBGP will carry it, so it gets from one edge to the other. Route reflectors will carry it, etc. There's a fortuitous little thing that Sharon's going to rely on extensively, which is, here's a stub AS. They don't provide transit to anybody. They're, the widget manufacturing company or Bill's Bait and Sushi. Okay? They will trust their two upstream providers to have done full validation. So they receive announcements without all the crypto glop, et cetera, et cetera. They trust their upstreams. But they want to protect their prefix or prefixes when they're announced. So they have the private keys to match the RPKI stuff. And they sign their announcements, but that is trivial. So they sign their announcements and send them out. And this could be done on the dinkiest of routers today. No hardware increase. Okay? It's designed to be incrementally deployable. It will be islands of growth, and Sharon will discuss extensively deployment scenarios. There's no increase of operator data exposure, as I said. Okay, no IRR-style publication of who my customers or peers are. It works for confederations, it works for route reflection, etc. Note that confederations are eBGP boundaries, actually, but the sub-AS should not sign towards the core. It only covers prefix and path. It doesn't cover communities because we don't understand their security semantics. If we did, we might sign over them. The protocol, as described in the internet drafts that are sitting in the IETF today, is utterly unoptimized. We wanted to get the semantics and the security properties correct first. It's assumed that optimizations will be worked out. One optimization would be you don't want path prepending, which, discussing as it is, I bet you there are people in this room who use it. And you don't want to have to sign this thing 5 times as it goes out. That's an optimization we might do, and here's even an example of it. We could add one more little attribute, little thingy called a prefix count, a prepend count. So that I say, hey, my S is 0 and presume it's prepended n times. Now, one of the problems with forward signing, as probably I have a slide ordering problem, is that I can't use this in the presence of AS transparent route servers, which some people like to use. In other words, I hand it to the route server, it hands it on, and that route server doesn't add its AS. I can't do that with a simple BGPsec because I have to forward sign towards the target AS. I have to know that AS's number. Okay? So what if we let the transparent route server sign with a prepend count of 0, so we don't care that that signature's there, because the rule of the game is downstream ASs, when they want to do AS path length comparisons, do it on the sum of the prefix counts. Dirty hack, 13.4. But now we're talking about optimizations. We're refraining from them at the moment, but we're starting to peek at them. As I said, it uses the global RPKI. It assumes origin validation. This is just another BGP decision. Okay? The router is going to look at this and say, yep, that was cryptographically valid. Nope, it was cryptographically invalid. And you, in your policy, decide what to do about that. Okay? You might up-pref all valid routes. You might drop invalid routes, or you might keep them. Or I always like to give the example of my friend Steve Bellovin, who's a security researcher, and he likes to collect invalid routes only. Okay. Some of the consequences. New hardware generation, RAM is the big problem. The RAM problem is exacerbated. Well, here's a NIST study. It shows the projected curve, et cetera. You know, growth is not that bad. You're talking about, 2020 for 8 gig of RAM on the router with certain deployment scenarios and the spreadsheets out there and available. The problem is that the routers today, most of your routers, you don't really think of it, have a 32-bit addressing model in their code. So this is going to be a new generation of hardware. This is science fiction. There's no PDU packing. As I said, transparent route servers are in trouble. Proxy aggregation, i.e. AS sets, is not supported, and there's an internet draft in the IDR working group saying AS sets are gone. We've done actual measurements. Their use is trivially small. Okay? That's about it. Oh no, one more thing is, it does not lock the data plane, and in other words, packet forwarding to the control plane, i.e. routing. And I never did this presentation here, but I've done it in a number of other ops meetings, and it was a paper from 2009 IMC. It turns out 70% of the ASs in the internet have some form of default. Remember when everybody started screaming at me because I used AS path poisoning? Well, this is why we did it. So, but there's no sense locking the data plane to the control plane until you've locked the control plane and made it secure. So one step at a time, purpose here is to give you a cryptographically, formally secured control plane. We think this can do it. We think this is, we're talking about 5 years from now plus. But we think this is a valid approach, and we're now working it through the IETF as design goes. We should fess up to this work is sponsored by the Department of Homeland Security to do open source, make the internet a better place. They take your scissors away, we try to turn them into plowshares. And that's it. Questions?
Mike Smith from AdHost. What happens if you get into a situation where somebody signs, somebody doesn't sign, somebody signs, somebody doesn't sign?
This is a continual argument we have. We call it partial path signing. Currently, it doesn't allow it. If I have a neighbor who doesn't speak BGPsec, I strip. The argument goes, the left-hand side says, I have a route that's unsigned, 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 signed, 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 signed. What's the meaning of that from a security viewpoint? That could all be utter garbage over on the left-hand side. The other side of the argument says, well, there were 5 hops we at least knew were signed. But the current proposals do not allow partial path signing. You heading for a mic or the loo? A mic.
David Miles from Alcatel-Lucent. Just a question, Randy, for you about the use of RSA or the use of public-private certificates. Has there been consideration made to the use of alternatives like ECC that may be easier for router manufacturers to implement? In terms of performance, I should say.
The RPKI X5i9 infrastructure, as described, is RSA-based.
Right.
The router signatures are, the protocol description is Agile, but the protocol description is being currently changed that the initial being used is ECDSA.
Okay, thanks.
Make you happy? It was felt that the deployment window for this was far enough out that ECDSA will be widely available in Fly.
Hey, Eric Osterwald, Verisign Labs. I just had a quick question. I didn't completely follow the routers that generate their own keys and upload them. Could you explain how that works exactly? Like,
So we need the certificate blobs, signed blobs for each router. The signed blobs have a public key. The only place the private key is needed is in the router because the router wants to sign with it. So the router, just like it does in SSH today, could generate its own private key. You'd say crypto blah, blah, blah in a Crisco. And it would generate the private key, would give you the public key, and you would hand it to the RPKI and say, here's my public key, give me a router cert for it.
Okay, so I was just wondering if routers are able to essentially generate their authentication credentials, which are these keys, that they can then use to sort of authenticate paths. Is there any sort of entry authentication so that I can't, intrude in your network and stand up a rogue agent that uploads a key and looks like a valid signer?
Well, if you wanted to do the router generates its own key game, then the path by which that gets into the RPKI is going to have significant authenticity. Okay? And one of the ways you might do that is wrap it in something signed by the AS, for example.
Okay.
So this cert has a private key somewheres, and so I could take the request, wrap it in that, And at least you wouldn't know that this was the exact router doing it, but you'd know it was the same administrative authority.
Gotcha. Okay, thanks.
Sharon?
Yeah, we appreciate that.